You are welcome to today's lesson. We are continuing our discussion on series and sequence, and the subtopic for discussion is geometric progression. In our previous lesson, we discussed arithmetic progression, that is the nth term and also the sum of the first nth term. And in this lesson, we shall study geometric progression. In the same way, we are going to learn how to find the nth term of a geometric progression and also the sum of the first n terms in a geometric progression. What is a geometric progression? A geometric progression, which is also termed as GP, refers to a sequence in which each term is found from the preceding term by multiplying by a constant factor. In other words, to find the next term of any geometric progression, I need to multiply the previous term, which is the preceding term, by a constant factor. This constant factor is called the common ratio and is denoted by the letter R. Let's look at an example of a geometric progression. And the first example is 3, 9, 27, 81. This sequence represents a geometric progression because the sequence has a common ratio. And the common ratio for this sequence is 3. This is because when I divide the number 9 by the preceding number, which is the previous number 3, it will produce the ratio 3. If I divide the next number, which is 27, by the previous number 9, it will also produce the common ratio 3 in that order. Another example is 4, 8, 16, 32. And this sequence is also a geometric progression because it has a common ratio 2. This is because when I divide the number 8 by the previous number 4, it will produce 2. In the same way, when I divide 16 by 8, it will produce 2 in that order. And this is the difference between arithmetic progression and geometric progression. Remember, in arithmetic progression, we were talking about common difference. But in geometric progression, our focus is on common ratio. Let's talk about the general term of a geometric progression. Let u1, u2, u3 up to un be any exponential sequence. In other words, u1, u2, u3 up to un is representing a set of numbers in a sequence, with the first term noted as a, which is 3, and the common ratio r is 2. It therefore follows that the first term is represented as u1, and the value for u1 is 3. Remember that 3 was the value given as the first term or the first number. How do I get the second term, which is u2? u2, which is the second term, is given by the previous term, which is the previous number 3, multiplied by the common ratio, which is 2. Remember, we said in the definition of geometric progression that to get the next term in any geometric progression, we multiply the previous term, which is the preceding term, by the common factor, which is also known as the common ratio. And so in this case, the previous term was the number 3 multiplied by the common ratio 2. How do I get the third term, which is u3? In the same way, u3 is given by the value in the second term multiplied by the common ratio 2. Remember, in the second term, we got 3 times 2. And so that same 3 times 2 multiplied by the common ratio 2. And that will produce 3 times 2 raised to the power 2. And that produces the value for the third term. To get the fourth term, in the same way, we are going to multiply the answer we had in the previous term, which is in the third term. We multiply it by 2. And so in the third term, we had our solution as 3 times 2 raised to the power 2 multiplied by the common ratio 2, and that will produce 3 times 2 raised to the power 3. Now we can continue this sequence by finding the fifth term, the sixth term, and the terms beyond. And so to find the fifth term, which is represented as u5, the fifth term is given by previous term, which is the value we had for u4, which is 3 times 2 raised to the power 3, multiplied by the common ratio, which is 2. And that will produce the fifth term to be 3 times 2 raised to the power 4. And so let's look at the pattern in finding the number of terms or the next term. u5 is producing the value 3 times 2 raised to the power 4. What do you think will be the next term, which is u6? u6 will also be given by 3 times 2 raised to the power 5. And so you observe that as the terms increases, the power also increases. The next term, which is the seventh term, will also produce 3 times 2 raised to the power 6. So as we move on, or as we continue the sequence, the power will keep increasing. Hence, in general, if the geometric progression, which is GP, has the first term denoted by A and a common ratio R, we can find the first 4 terms of the geometric progression. To obtain the first 4 terms, we need to know the first term, the second term, the third term, then finally the fourth term. The first term is given by U1, which equals A. And remember that A represents the value of the first term. How do I get my second term? Remember that the second term of a geometric progression is given by the first term or the previous term multiplied by the common ratio R, and that produces AR. How do I get the third term? The third term is also given by the previous term, which is the second term, AR multiplied by R, and that will produce AR squared. The fourth term will now also give us AR cubed. Now, let's observe that the third term, the number of terms here is 3. When I subtract 1 from 3, it will produce the exponent of the third term, which is R squared. The fourth term has the number of terms to be 4. When I subtract 1 from 4, it will produce the exponent of the fourth term, which is R cubed. And so in this sequence, the first term here is A, the second term becomes AR, the third term becomes AR squared, and the fourth term also becomes AR cubed in that order. And so the nth term of an exponential sequence or a geometric progression with the first term A and the common ratio R is given by U subscript n equals A multiplied by R exponent n minus 1. In other words, if I want to find the number of terms of any exponential sequence or a geometric progression, it is given by U subscript n equals the first term multiplied by the common ratio exponent the number of terms, which is n minus 1. And to derive the common ratio, it could be given by the second term divided by the previous term, which is the first term. Or when I choose to pick the third term, I will divide it by the previous term, which is the second term, and they all produce the same answer, which is the common ratio. Let's look at an example. In this example, we have to find the nth term of an exponential sequence, which is also known as a geometric progression, of the form 10, 20, 40, 80 in that order. To find the ninth term, I will need my sequence, which is given by 10, 20, 40, 80 in that order. And remember that to find the number of terms of any geometric progression or exponential sequence, it is given by U subscript n equals A multiplied by R exponent n minus 1. And in this question, the number of terms was given as 9 because we are looking for the ninth term. And the first term in this question is 10, which is represented as A. How do we determine the common ratio? The common ratio could be determined by dividing the number 20, which is the second term, by the previous term, which is the preceding term, the number 10. So 20 divided by 10 will produce 2. If I pick any other term, let's say the third term, which is 40, and divide it by the previous term, 20, it will produce the same common ratio 2. And having our formula, we can substitute our values. And so now this becomes U subscript 9 equals the first term, which is 10, multiplied by the common ratio 2, exponent n, which is 9 minus 1. And to simplify further, 9 minus 1 will produce 8. And in all, the ninth term of this geometric sequence is given by 2560. Let's look at another example. In this example, we have to find the 12th term of the geometric progression 128, 64, 32 in that order. And this is the sequence given to us to find the 12th term. And to determine the 12th term, we need to know the formula for finding any number of terms for a geometric progression or an exponential sequence. And that is given by U subscript n equals A multiplying R exponent n minus 1. And we know n to be 12, which is the number of terms we are looking for. The first term is also denoted as 128. How do we get the common ratio? Remember that the common ratio can be found by dividing the second term by the previous term, which is the first term, and that becomes 64 divided by 128, and that will produce a common ratio half, or 1 out of 2. If I pick the third term, 32, and divide by the previous term, 64, it will also produce the same common ratio as half, or 1 out of 2. Now we can substitute our values into our formula, and that produces U12, which is the 12th term, is given by the first term, which is 128, multiplied by the common ratio half, or 1 out of 2, exponent the nth term, which is 12 minus 1. And 12 minus 1 obviously becomes 11. And in conclusion, the 12th term of the geometric progression is given by 1 out of 16. Let's take a look at our assignment for this lesson. We have to find the 7th term of an exponential sequence of the form 5, 10, 20, 40 in that order. And finally, we are also to find the 11th term of an exponential sequence of the form 324, 108, 36, 12 in that order. Thanks for watching, and see you in the next lesson.